6.9 practice problems. Based off of the information for the two different reactions given above, which of the following gives the quantities needed to calculate the enthalpy change for the reaction represented by the overall equation below? So we have dinitrogen tetraoxide decomposing into nitrogen dioxide as reaction 1, but that is a reactant, and we end up with it as a product. So we do need reaction 1 to be inversed, so we need negative of this. So I'm going to eliminate anything that doesn't have the reaction 1 as a negative, which only leaves me with option C. And then we would see this here, and it is going to be in the correct direction, so it's going to be positive, so option C is my answer choice. Based on the chemical equations and their associated enthalpy changes shown above, which of the following identifies the quantities needed to calculate delta H of formation if the standard enthalpy of formation for water in kilojoules? So we have our overall net equation being 5, so I shouldn't see 5 anywhere in here, and I don't, so I can't eliminate any of those options just because of that, unfortunately. Then I need to go ahead and see if any of the reactions are not in the correct direction, and I'll know that I'll need to inverse their sign. So I can see that reaction 1 and 2 both need to be inversed. So I'm going to go ahead and put a minus next to them just to tell me that I need to inverse those reactions. And then I see that reaction 3 is in the correct direction, so that can stay the same. And then I am going to see that I do need it in liquid, and this is in the correct direction, so that can stay the same as well. The last thing that I do need to notice is that for the coefficients here, I have a half coefficient here for O2, so this also needs to be halved. So not only reversed, but also halved because of the coefficients needing to be halved. So I'm going to look to see if I can match any of those. This can stay the same since we do need the full H2. So anything where H is not inversed, I'm going to eliminate. I'm going to eliminate the one that also has a coefficient change for the reaction 1 here, since I do not need that. It doesn't need to be changed at all. And then I'm looking for the H2 to be not only inversed but halved. And this one has the half but not the inverse, so that leaves me with just option choice B. 3 and 4 both need to be there, and they are not changing their sign. So option choice B is fully correct, so that is going to be my answer choice. Okay, question 3. Which of the following combinations represents the individual reactions and the quantities needed to determine the delta H of the reaction for the overall reaction represented by the chemical equation? So we're going to be looking for things to be in the correct direction, and everything to end up netting out appropriately. So as I look through here, I'm going to eliminate anything that appears on the left-hand side and on the right-hand side. So oxygen appears in the same proportion on the left-hand side and on the right-hand side, and so does sulfur dioxide, leaving me with the net equation that does match the stated equation, so that looks good. We'll check all the other ones. Here, the only thing that I am able to do is eliminate one SO2, and then this is 3 halves O2, so I get to eliminate 3 halves of this, or 1.5, so this would end up being 1.5 remaining, and that these do not match this overall net equation, so that's going to be eliminated here. The oxygens are going to add up, so are the sulfur dioxides here, and nothing else is eliminated. That does not match my equation, so no. Here, my sulfur dioxides are going to add up, and so are my oxygens are going to add up. So option choice A is the only one where my net equation is going to be the same as my overall equation. So that's the only possible reaction pathways that give me what I need. The enthalpy change for the reaction represented above is delta H. This reaction can be broken down into a series of steps as shown in the diagram. The reaction must exist amongst the various enthalpy changes is. The relationship that must exist amongst the enthalpy changes is. So we have A to X being the delta HT. And remember that the delta HT has to be equal to all three pathways combined. So delta H1 plus delta H2 plus delta H3. Okay, this is my stated relationship. And so I'm going to eliminate anything that doesn't have that added up. So obviously the easiest ones to go ahead and eliminate are the ones where delta H is still isolated, since that is what I have here. Delta HT, sorry, is still isolated. So C and D are going to be eliminated because they do not match my required pathway there. Then I'm going to look at the ones where delta H is not isolated and see what happens. So if I want to move delta H2 to the left-hand side, I do need to subtract that. So that's the wrong sign here, so that's why I am eliminating that there. And then if I wanted everything on the same side, either I would have to subtract delta HT to get over here, or I would have to subtract all of these here. So this is the wrong sign for all of them here. Option choice A is the only one that has the correct signs on all of my delta H pathways. So option choice A has to be my choice. Based off of the information above, what is the enthalpy change for the sublimation of iodine represented below? So we are going to make sure that we are going in the correct direction, and we are going from solid to gas, and so this does need to be flipped here. And then I need to go ahead and make sure that I am dealing with the correct number of coefficients. So I do need to go ahead and make sure that this is in the correct coefficients here. So this is currently halved, so I do need this times 2. And then this also needs to be multiplied by 2 as well, and the sign needs to be changed. So 26 times 2 gives me 52. And then negative 5 times negative 2, basically, because it's flipping the sign and then multiplying it by 2, gives me 10. And I'm going to add those up, and that gets me to 62 kilojoules per mole, which is going to be my final answer.